I want to spend a little bit of time reviewing some concepts that we've already talked about with integrating, but now looking at them in terms of what happens when natural logarithms are involved. So basically 2 concepts, 2 examples, one for each. The first one being what happens when I do use substitution and I have that extra variable. It's going to work the same way when we come up with an answer involving natural logarithm as it did when we did not come up with an answer involving natural logarithm. So I'm just going to go ahead and walk through this first example. I notice that when I try to integrate it, I run into issues because, again, I have this rational function where on top I have the 2x, on the bottom I have x plus 1 squared. There's not a lot I can do with it, mainly because of the fact that it is not a monomial, so I can't just bring it to the top. I don't think long division is going to be very helpful for me, mainly because if I did try to FOIL this out, then I would not be able to divide 2x by it, since I'm after FOILing would get an x squared. So I'm going to go ahead and try to use u substitution. I'm going to go ahead and try letting u equal x plus 1, giving me du equaling 1 dx. Is it, hopefully it's okay that I skip that kind of intermediate step. If it's not, please make sure that when you come into class the next day that you are talking to me about where that intermediate step went. Now I'm ready to put x plus 1. I'm going to put u in for x plus 1 and du in for dx. The issue that I'm running into is I have both an extra 2 and an extra x. Well, remember, if I have constants that I don't want, I can pull those out to the front. So I can bring the 2 out to the front. Multiplying the 2 on the inside or the outside makes no difference. However, the x, if you remember from what we discussed before when we have extra variables, the x I can substitute with u minus 1, since according to what I did here, what I made my substitution for, if I subtracted 1 from each side, it would tell me what x is. So I'm going to go ahead and substitute that all in, and I will have 2 on the outside, pulling that out front, times the integral. In place of that x, I will have u minus 1, all over, in place of x plus 1, u squared, and in place of dx, the du. Well, now I can integrate this, not necessarily as written, but I know that it's a quick, simple fix to bring that up, make it a negative 2, and distribute it in. So I get 2 times the integral of u minus 1, u to the negative 2, du, which gives me 2 times the integral of u to the negative 1 minus u to the negative 2 du. Well, from here you might say, wait a second, when I try to use my traditional rules, I end up with 1 over 1 plus negative 1. That's not working for me. But remember, u to the negative 1 is the same thing as 1 over u. So if I think of it in terms of 1 over u, well, I just know that that integrates to be the natural logarithm of u. So this gives me 2 times ln, absolute value of u, minus, if I go ahead and integrate this, I do end up with 1 over negative 1, or excuse me, 1 plus a negative 2, which is just going to be negative 1, u to the negative 2 plus 1, which ends up being negative 1, plus c. So if I just clean this up a little bit, I'm going to go ahead and distribute my 2. I get 2 ln, replacing u with x plus 1. Minus a minus 1 over here is going to end up being a plus. And again, in place of u, x plus 1 to the negative 1 plus c as my final answer. If I look at my next example, is on a concept we have already covered once again. I'm finding the average value. So average value, I need to know what my average value formula is. Well, I know that my average value is 1 over b minus a times the integral from a to b of f of x, where a and b stand for my interval that I'm given. So if I look at this next problem, or this one example on solving for average value, it says to find the average value of the function over the given intervals. So I have f of x equals natural log rhythm of x all over x from 1 to e. So I'm just going to go ahead, since I'm solving for average value, I'm going to plug it into my average value formula, and I will have 1 over e minus 1. I always do the larger, or the right endpoint minus the left endpoint. Remember that e just stands for a number. It's about 2.78, similar to pi in that regard, times the integral from 1 up to e of ln of x over x dx. So if I try to integrate this, the problem that I'm going to run into is, once again, I cannot integrate with division. So I have to figure out a way to rewrite this integral. So notice most of the time when we're integrating, we're running into a situation where how can I rewrite the integral so that I can actually do my integration? Well, maybe I'm looking at u. So we've been typically letting u be the bottom. So let's try that. Let me let u equal 1. Well, then du, let me let u equal x, not 1. So then du would be 1 dx. Well, that lets me put u in for x, and it lets me put du in here, but what am I going to do with ln of x? Rather than try to deal with that, because even if I put u in for x here and had ln of u over u, I'm running into the exact same situation as when I had ln of x over x. So what if I tried, instead of having u be x, what if I tried to let u be the top and be ln of x? Well, then my du would be, remember the derivative of ln of x would just be 1 over x dx. Well, that's really helpful, because isn't this the same thing as 1 over e minus 1 from 1 to e of ln of x times 1 over x dx? And then I have a place to put my u and a place to put my du. So since that worked out so nicely, I'm going to go ahead and do that, and I will have 1 over e minus 1 times the integral from 1, actually, back up a second. Okay, so backing up, now that I fixed my page, all I wanted to do was say that I can't plug back in the 1 and the e. I have to remember change those to be in terms of u. So I do need to go ahead and say, well, if u equals ln of x, if x equals 1, then u equals ln of 1, which just equals 0. This is something we covered last year in trigonometry in terms of how to solve this. If you're not sure where this 0 is coming from, please let me know and I can show you that very quickly. And then if x equals e, u equals ln of e, which just equals 1. Same thing as here. If you're not understanding where this 1 is coming from, please let me know, and I can show you it fairly quickly. Excuse me. So my lower limit will not be 1, it'll be 0. My upper limit will not be e, it'll be 1. And then I have plugging u in for ln of x and plugging du in for dx. I do end up with 1 over e minus 1. The integral of u ends up being 1/2 u squared from 0 to 1. So if I plug in 1, I end up with 1/2 times 1 squared. If I plug in 0, I end up with 1/2 times 0 squared. So this will simplify when I plug in the top and then subtract the bottom. 1 over e minus 1 times 1/2, and that would be it. I could, if I wanted to, rewrite this a little bit better. Oh, and I want to say my plus c. Oh, no, I do not want to say plus c because I had an upper and a lower limit. So I could rewrite this a little bit better and say this is the same thing as 1 over 2 times e minus 1, which I could approximate with my calculator if I wanted to. Sorry about that slip up with erasing some of the work here, but hopefully this makes sense. If not, we can talk about where you kind of fell off tomorrow in class. All right?